This module, I feel, is going to confuse a lot of people in that it's going to take them by surprise. Not necessarily that the topics will be confusing, but it will take them by surprise because you'll be going along at a certain level, and then it hits around 18 or 19. It's going to start swinging wildly back and forth between stuff you did in math class and you could be able to do pretty quickly and things that will have you staring at it going, what on earth is going on? It's a fun one. So without further ado, let's get started. Here's number 1. The scatter plot shows the temperature in degrees Fahrenheit and the distance above sea level in feet measured at 6 locations on Mount Jefferson. A line of best fit is also shown. At a distance of 4,000 feet above sea level, what is the temperature in degrees Fahrenheit predicted by the line of best fit? So the dots that we see, anytime we have a scatter plot, it's just dots of data. They're showing us dots of data. So we have these 1, 2, 3, 4, 5, 6 dots, and they are showing these 6 locations, their distance above sea level, and what their temperature was. And a line of best fit in a scatter plot is a line that is trying to show an overall trend. When it's the best fit, it's the line that when you draw it through all the points, it is the shortest average distance vertically from each point. Now on the SAT, they do not ask you to come up with a line of best fit. There will be questions about it, but the questions generally are something like this, where they're asking you to ignore the dots and just look at the line of best fit and see what it predicts. Or they will give you a chart with a line of best fit and then give you, they will give you, your 4 options, A, B, C, and D, of equations of lines and say which of these equations best fits that line. And honestly, for those, it doesn't really matter if it's the line of best fit. It's just which of these equations fits that line. This is one, as I said, where they're just asking you to look not at the dots, but at the line itself. And they're saying at 4,000 feet above sea level, which is this bit right here, what is the temperature predicted by the line? So we just look for, that, as I can't draw straight to save my life. There we go. And we look for where it's hitting, what that Y, I can't quite get it on that line, but that's close enough. You know what I'm doing there. They want you to get right, there we go. That's better, perfect. You want to see what is that Y value. And it looks like it's crossing right there at 35 degrees is where that line of best fit is at 4,000. And that is B. My answer is 35. Number 2, rectangle P has an area of 72 square inches. If a rectangle with an area of 20 square inches is removed from rectangle P, what is the area in square inches of the resulting figure? We do not have to figure out what the lengths of the sides are for this rectangle. It doesn't matter. So all I know is I have a rectangle and it has 72 square inches. So it's like, you see those little squares that are in the bottom? It's like if you counted out, there would be 72 of them inside this rectangle. And I did not draw it to scale. I actually could. Let's actually, why not? Why not? Let's draw this thing to scale. Let's start right here. And we go 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So there is this rectangle that looks a lot like a square, but it is actually a rectangle. It is slightly wider than it is long. And I drew it 9 by 8 so that it would be 72 square inches. And it's saying, and this could be, there's a lot of varieties of rectangle this could be. This could be 2 by 36 inches. There's variety here. It doesn't matter. What matters is that there's 72 square inches. So if I remove 20 square inches, so that'd be like, so if we did 1, 2, 3, 4, actually no, 1, 2, 3, 4, 5, 1, 2, 3, 4. I'm removing 20 square inches. Those are now gone. What is left? Well, we just have to subtract because we're just taking away those 20 out of this total 72. So we don't have to do anything more complex than that. We just subtract 72 minus 20. That gives us 52. And that is our answer, D. This one, honestly, they're being really nice with the answers. Look at these answers here. They have 92, 84, 80, and then 52. And here it's saying it starts at 72 and a rectangle with an area is removed from it. inches are removed. Anytime we're removing inches, we're taking away. So the answer would have to be less than 72. Even if you weren't sure, oh, do I need to figure out the area? Do I need to draw this little diagram? I mean, do I need to figure out the lengths of the sides? What do I do? Just by looking at these answers, there's only one answer that is less than 72, where something has been removed from 72. So a lot of times those answers can be helpful and actually give us really big clues as to what the answer is. But that is our answer, D, 52. Number 3, the absolute value of p plus 61 equals 65. Which value is a solution to the given equation? Absolute value really means how far away is a number from 0 on a number line. So if I have a number line, and this is 0, 2 and negative 2 have the same absolute value because they're both 2 away from 0. In practical, what you're going to use this for terms, it means make it positive. It means if it's positive, if p was positive, it stays the same. If p is negative, it becomes positive when you take its absolute value. So anytime you're solving an absolute value equation, you have to account for both options. What if p is positive? What if p is negative? And solve for both. So here we have the absolute value of p plus 61 equals 65. So the 61 is not inside the absolute value, so we can get rid of it first before we deal with the absolute value. And by get rid of it, we undo what's happening to it. It's being added, so we're going to undo that by subtracting. And on the left, we are left with the absolute value of p is equal to 65 minus 61, or 4. So because p could have been positive or negative, what you do is, and this is the principle that you're going to follow when it's a little more complex inside the absolute value. Like say if it was, p squared minus 9, or, 3p plus 5, absolute value equals something. The way you do that is you take that, whatever's inside the absolute value, you take this something over here, you have one where it's positive, one where it's negative, and you set this equation equal to the positive and the negative, and you go through the process and you solve for p 2 times. And that gives you your answers. I'm telling you this because, next time they might not be so nice. You might not get one where it's just absolute value of p. It may be like 3p plus 5 or something like that, like I just said. Okay, so you take what's inside the absolute value, you write it twice, and one time you set it equal to the positive version of this, and one time you set it equal to the negative version of this. And then if there's any math to be done, any algebra to be done, to solve for p, you do it. Here we don't have to. P could be 4 or it could be negative 4. Only one of those is an option, and it is B4. That is my answer. Number 4, Lorenzo purchased a box of cereal and some strawberries at the grocery store. Lorenzo paid $2 for the box of cereal and $1.90 per pound for the strawberries. If Lorenzo paid a total of $9.60 for the box of cereal and the strawberries, which of the following equations can be used to find P, the number of pounds of strawberries Lorenzo purchased? Assume there is no sales tax. Okay, these I like to kind of write out an equation before I look at their answers. I do tell you a lot of times to look at the answers first. This one I say, no, I'm going to come up with my own first. Because these are so close to each other, when you look at them at a glance, like, whoa, those are really close. I don't want to get confused and accidentally pick the wrong one. So let's break this apart. First, he paid $2 for a box of cereal. Just one box of cereal, he paid $2. Okay, flat rate, he paid $2. Then what else did he do? He paid $1.90 per pound for the strawberries. But we don't know how many pounds of strawberries. It says P is the number of pounds of strawberries. So it's $1.90 per pound, and we don't know how many pounds, so $1.90 times however many pounds he bought. And when they added those together, because those are the two things that he purchased, his total purchase price was $9.60. Now, if I were to solve for that, I would be able to find out what the price of strawberries per pound would be. So that is my equation. I've got my $2 for the box of cereal, $1.90 per pound for a total of $9.60, and they were added together. And so let's look over here and see which of these matches. The first two use $1.90 times P. The second two use 2 times P. So nope, I know. It's like, no, those do not match. I'm looking at the $1.90 for P, and I have 2 being added And that is A. There's the 2 being added. No, we do not want to subtract 2. So A is my answer. Number 5. The bar graph summarizes the charge in kilowatt hours a battery received each day for 15 days. For how many of these 15 days did the battery receive a charge of 0 kilowatt hours? Okay, so if I look down here, these are my kilowatt hours. I look for 0. There it is. Then I follow the bar graph up to find my number of days. And it says the number of days up here is 6. So for 6 days out of the 15, the battery received 0 hours of charge. That's D, 6. So yeah, sometimes they have these on there that don't ask you to do any math. They just ask for your bar graph or histogram reading skills. Yeah, so if you see the term histogram on here and go, like, what is that? I haven't heard that one before. A histogram, it's a bar graph where they touch. It covers a range. That's the difference. They're going to touch. The bars are going to be touching each other. And they're going to cover a range like 0 to 10. This one's 10 to 20. This is 20 to 30, like that. And that bar is 0 to 10. That's the difference. So if you see something described as a histogram and you're like, oh, it looks like a bar graph to me, that may be why. But yeah, this is just a test to see if you can read a bar graph. And the answer is D, 6. Number 6, a line in the xy plane has a slope of 9 and passes through the point 0, -5. The equation y equals px plus r defines the line where p and r are constants. What is the value of p? I honestly looked at this one. I'm like, am I missing something? Like, it looks like the answer is just right there, that I don't have to do any math, that they've just given me the answer. And I read it again and I go, yeah, I think so. And that was the case. And why do I say that? They just gave us the answer. This equation right here, y equals px plus r. If you've studied linear equations, I'm hoping that looks an awful lot like the slope-intercept form of a line. I'm hoping that triggers that in your brain and you go, hey, that looks a lot like slope-intercept. Because that's going to help you right here. That's what you want to have. That you go, okay, y equals mx plus b, because it's telling me p and r are constants. That's a constant, that's a constant. And slope-intercept, that's a constant, that's a constant. So p is corresponding to m and r is corresponding to b. Well, in the slope-intercept form, as I erased my b by accident, the m there is the slope. And the b is the y-intercept. And since p is the same as m, and m is my slope, when they ask what is the value of p, the very first thing here says a line has a slope of 9. That's it. P is 9. So we don't have to do any calculations. We don't have to graph anything. We don't have to try to figure out, oh, that has a slope of 9. It goes through this point, and then I have to figure out plugging in x and y. No, no, no. Don't have to do any of that. We want to recognize that it is already in this slope-intercept format. And so there's a 1-to-1 correlation. R is B, which is the y-intercept. P is M, which is the slope. And they've already told us both of those. They've told us the slope and they've told us the y-intercept. Yeah, they're just asking for the slope. They've told us the slope. The slope is 9. 9 is the answer. That's it. Sometimes I think problems like this can be, they can, kind of disrupt a student because they look at it and they go, it can't be that. It can't be that. It's right there. They're just saying, P is the slope and the slope is 9. What is P? And you're like, it's 9, right? What am I missing? There's got to be something more going on here. Sometimes it isn't, but yeah, you can overthink things. Believe me, I've done that many times. I overthink things. Number 7, what is an x-coordinate of an x-intercept of the graph of y equals 3 times x minus 14 times x plus 5 times x plus 4 in the xy plane? You do not have to put this into your graphing calculator. You do not have to distribute it. In fact, I would highly recommend you don't do either of those things. They like this kind of problem where they give you a polynomial that's been factored. This here would be an x cubed. We have an x times an x times an x there. There's going to be 3 the x is going to be multiplied by itself 3 times, so it's going to be a cubic. An x cubed will be in there. It's going to have, it's got this 3 out front. It's going to have a 3x cubed. What else is in there? I don't know. Frankly, I don't care. It doesn't matter. You know why it doesn't matter? Because our answer is looking at us right in the face. We don't actually have to do any real, we'll call this quote unquote real math. When you factor a quadratic, because most of us have experience factoring quadratic, not necessarily factoring cubics, we will end up, when we factor, with something like x plus 3, we'll say, times x plus 1, and that equals 0. And if you've done that, and I'm hoping you have, because that should be a part of your SAT prep, is learning how to factor, the way you solve for x and you find a solution of the quadratic is you set each of these equal to 0. Because when they multiply together, they get 0, so one of them has got to be 0. And then you're going to solve for each one. You subtract, in this case, a 3 from both sides to get rid of that 3. And you have x equals negative 3. And this one, you subtract 1 from both sides to get rid of that 1. And you get x equals negative 1. And when you do these a lot, you start to realize, you get this little pattern, that if it is a single x, there's no coefficient in front of the x, that the answer you're going to get is the opposite of this. Every time. So this is positive 3, you're going to get that x is negative 3. This is positive 1, you get that x is negative 1. Again, that's only when it's a single x, not a coefficient. A coefficient changes things. Well, look here. I've got 3 of these things being multiplied together. And when it says the x-coordinate of an x-intercept, the terms that get reused, they are interchangeable. They're going to see all of these, so know that they all mean the same thing. They are the solutions of a polynomial, the zeros of a polynomial, the roots of a polynomial, or the x-intercepts of a polynomial. They are all the same, and the SAT uses all 4 terms, depending on what the problem is. All of them. Know that they mean the same thing. So it just means whatever the quadratic is, it's the spots where it crosses the x-axis. Those are the solutions. So it's going to be where the y value is 0. So where it's 0 equals, so we're putting in a 0 for y, 3 times x minus 14. Get rid of these for a second. Erase that. X minus 14 times x plus 5 times x plus 4. So just like that quadratic we just looked at, each of these, you set it equal to 0 separately. And just like I said, that pattern that you start seeing when you don't have a coefficient in front of the x, the solutions are just the opposite of these terms. So the solution here, the opposite of negative 14 is positive 14. The opposite of positive 5 is negative 5. The opposite of positive 4 is negative 4. And those are my 3 solutions. That's it. So this is one of those things, again, if you practice this and you have this knowledge, as soon as you see this, don't waste your time graphing it. I want you to be able to practice this and recognize this so that when you look at it, you just go, oh, they're looking for an x-intercept. That means a solution. They've already factored it for me. So, okay, 14, negative 5, negative 4. Those are my 3 options. I pick any one of them that I want, and then I move on to the next problem. That is ideal. That's where we want to get to. Because as you will see, I mentioned this at the very beginning. I'm mentioning it again. As you get further in this particular module, you're going to see that the extra time that you save on things like this will come in handy. You want to get through these more straightforward problems that are just asking you to recall and use information that you studied and answer the problems that you've already seen these practice problems before. So when you get to these later ones where they just get kind of crazy, you'll have the time you need to focus on that. So yeah, for this one again, any of these is fine. 14, negative 5, or negative 4. All of those, just pick one. They do not say, this is key, they did not specify the positive solution or, an integer solution or a negative solution. Sometimes they do that. Here they do not. Always double check that. It just says an x-coordinate of an x-intercept. Pick any one you want and move on. Number 8. We have a graph here, and it says the graph shown gives the estimated value in dollars of a tablet as a function of the number of months since it was purchased. What is the best interpretation of the y-intercept of the graph in this context? A lot of times I tell you to look at the answers first. For these, when it says what's the best interpretation of a thing, I prefer to look at the graph first, make up my own mind about what I think the thing means, and then see which interpretation matches it. I say this because it's very easy to go through and read these 4 options and note that one of them or more of them, they are correct. Like you might see one and go, oh, that's a true statement about this graph. That's my answer. But just because it's a true statement about the graph in general doesn't mean it's answering the question. So let's look at just the question. It says, what is the best interpretation of the y-intercept of the graph? So at the y-intercept, we are at 0 months after purchase. 0 months after purchase means you just bought it, right? You bought it today. So let's say it was, January 1st that you bought this tablet. Probably couldn't because things would be closed then. Whatever. So you bought this tablet on January 1st. That is 0 months after purchase. So that point, that y-intercept, which appears to be 225 because it's halfway between 200 and 250, the value in dollars. So I'm saying that the y-intercept means that I paid $225. That's what I paid. That's what I bought it for. 0 months after purchase, $225. All right, so let's look at your options here. A, the estimated value of the tablet was $225 when it was purchased. That one looks like a solid contender. Let's double check the others because it does say best interpretation. B, the estimated value of the tablet 24 months after it was purchased was $225. Nope, we can see right there at 24 months after it was $50. C, the estimated value of the tablet had decreased by $225 in the 24 months after it was purchased. Even if that's true, I think that number is a little off. Let's see, it went from 225 to 50. Yes, that number is off. Even if this had been a factually true statement, it would not be the best interpretation of the y-intercept. And D, the estimated value of the tablet decreased by approximately 2.25% each year after it was purchased. I'm not going to do that math, but that may be true. And that's what I'm talking about when they say the best interpretation. Sometimes they put things in there that are true, but they are not the question. Here the question is, what is the y-intercept? And the y-intercept is A, that the estimated value of the tablet was $225 when it was purchased. That is 0 months after purchase. Number 9, triangles EFG and JKL are congruent. Okay, so let's say, boom, boom, boom. I have this poorly drawn triangle. I'm going to select it and I'm going to duplicate it. So, okay, I've got 2 congruent triangles here. And EFG, so okay, let's call this EFG. I didn't draw it to scale, but that's a little closer to what they did. I wasn't looking ahead. Shame on me. So E, F, and G correspond to J, K, and L. So I want to make sure I am writing corresponding. E corresponds to J, F to K, G to L. Okay. The measure of angle E is 45 degrees. Okay. And the measure of angle F is 20. Okay. What is the measure of angle J? Well, we don't actually need that angle F is 20. If we wanted to find out what angle G was, we would need that. But as far as saying what is J, E corresponds to J. We're told that E corresponds to J. In congruent triangles, corresponding angles and corresponding sides are congruent. Oh, I made that degree huge. There we go. So it's 45 degrees. That's it. We don't actually have to do any math on this one. If they had asked us for L or G, we would add those two together, subtract from 180, okay. Yeah, but no. Even if they'd asked us for K, we could say that's 20 degrees. No math is required, just a knowledge of congruent triangles, and that congruent means corresponding sides and corresponding angles are congruent. So it's very straightforward on this one. They're playing fair. The answer is B, 45 degrees. 10. The function f is defined by f of x equals 1/2 times x plus 6. What is the value of f of 4? When we have a function that is f of x, and we're asked what is f of a number, in this case 4, what they're saying is take your original function, take that 4, and everywhere there's an x, plug it in, and then do all the math. Well, in this case, there's only one x, so we only have to plug in at one point. Plug in that 4. And then we just do the math. 4 plus 6, our order of operations, we do the parentheses first. 4 plus 6 is 10. And then I multiply that by a half. A half times 10 is 5. So I plugged 4 wherever there's an x, plugged it into that original function. I did the math, and I got 5. So that is my answer. It is D, 5. Another term for this is evaluating a function. So that's another way this may be worded. If they say evaluate the function when f is 4, it means the exact same thing. You do the same process and get D, f of 4 is 5. All right, 11. The graph of a system of an absolute value function, that's this right angle looking thing, not quite a right angle, but looks like a V, and a linear function is the line there, is shown. What is the solution xy to this system of two equations? When they give us two functions and ask for the solution to this system, or what are the solutions, some of them have more than one, all it means is where do they cross? Where do they intersect? It does not matter if it is a parabola with a line, if it is a square root function and a parabola, whatever combination of functions it is, it just means where do they cross. And here they're being very nice, and they've highlighted this little spot right there where they cross. So if I look at this, this looks like negative 3.5 for my x value and a positive 4.5 for my y value. That would be the solution. It's where they cross. So let's see. Negative 3.5 is the same as negative 7/2 because I see they're giving us the answers in fractions just to make things fun. And 4.5 would be 9/2, 9 divided by 2. So that would be C, negative 7/2, 9/2, and that is my answer. So that one, just be careful, make sure that you have the right spot, but all you have to do is look at the graph there and see where the two functions intersect, and that's your answer, C. Number 12, y equals 6x plus 3. One of the two equations in a system of linear equations is given. The system has infinitely many solutions. Which equation could be the second equation in this system? When we have two lines, that's what a linear equation is, an equation of a line, and we have a system, so there's two of them, a system of linear equations with infinitely many solutions. All that means is it is a line right on top of a line. That's it. One line is right on top of the other one here. It's just right over top of it. So every single point is a solution to both of them. Now, if we're talking for linear, it just means they're going to have the exact same equation. So we need to look at these four and see which of these is the same as this one up here. Exactly the same as y equals 6x plus 3. Now, you can, and this is a very valid way to do it, you can put this in your graphing calculator, then put each of these four equations into your graphing calculator and see which one lines up directly over top of the first one. That is a valid method. My personal preference is to look at them and see if there's a way that I can do this more quickly than that. We always want to have time on our side on the SAT. We want as much time as we can on these earlier questions, save for those more difficult questions later on. So to get from y equals 6x plus 3 to one of these two, what's happening over here? In this first one, 2 is being multiplied by 6x, but nothing else. So if I distributed that, it would be y equals 12x, right? Plus 3. That is not the same as this. That 2 is only being multiplied by one thing. I need to find something where 2 is multiplying by this whole thing, because these all have 2's. There's 2's everywhere, so 2 is the key. So I want to find one where it's the same as 2 times everything. So let's look at it. This first one, nope, it's only multiplied by the 6. On this one, they're multiplying the right side by 2, but not the left. That one's out. See, we're getting closer. The left is multiplied by 2, but only the 6x is being multiplied by 2. The 3 is not changing, so that one's out. And our last one, the y on the left is being multiplied by 2, and the entire 6x plus 3 on the right is also being multiplied by 2. So that's our answer. Whatever's being done to one side has to be done to the other to keep it even, to keep it equal and balanced. So that's exactly the same. So I could divide both of these sides by 2 and get back to the original of y equals 6x plus 3. So they're the same. A little side note, when it says infinitely many solutions, as I mentioned, they are on top of each other. If it's a linear system and there are no solutions, it means they are parallel. In both of these cases, they will have the same slope. Both lines would have the same m in a y equals mx plus b form. If they are infinitely many, you can simplify them down so they both have the same slope and the same y-intercept. They will be the exact same equation when they are simplified. If they are parallel, they will have the same slope but a different y-intercept. So those two scenarios get used a lot on the SAT. Number 13. If 6/7 p plus 18 equals 54, what is the value of 7p? A lot of times with these ones where they say, what is the value of, instead of just asking for what is the value of x or what is the value of p, they ask what is the value of 7p. A lot of times there'll be something that you can do to this equation to get it to say what they're looking for equals blah, blah, blah. It's like a shortcut. This is not one of those cases. This is just an unusual one where they're like, all right, don't just put the answer. We're going to test and see if you're reading what is 7 times the answer. But just be aware of that. A lot of times there will be a way to get get to the answer quicker. But here we're just going to solve for p, and then we're going to multiply it by 7. So 6/7 p plus 18 equals 54. We want to undo what's been done to p. So we have this 18 that's been added. To undo that, we need to do the opposite. We need to subtract 18 from both sides. So we have 6/7 p on the left, and 54 minus 18 is 36 on the right. So to get rid of this 6/7 that's being multiplied by p, you multiply by the reciprocal, which is 7/6. I always have a hard time saying that. 7/6. And when you do that to both sides, on the left, those cancel out and you just have 1. So 1 times p is p. And on this side, because that's 36 over 1, I can do some canceling here. 6 on the bottom 1 time, 6 on the top 6 times. 6 times 7 on top over 1 times 1 on the bottom. 6 times 7 is 42. And this is where they're going to get you, because a lot of students, once they solve for p, they think they're done. And you're like, no, they didn't ask for p. They will forget that they asked for 7p. So they want 42 times a 7, which is 294. So 294 is my answer. I said there was a shortcut, like there's times where it'll be something like, 6p plus 5, equals 10, and they'll say, what is 6p? It's that kind of thing, where you don't have to solve for p and then multiply by 6, because 6p is somewhere in the original equation. It's that kind of deal. Those show up a lot. It's never a bad idea to look for that kind of thing to see if there's a shortcut where you don't have to solve for p and then multiply by 7. But in this case, there isn't one of those. You do have to solve and then multiply by 7. But it gets you to our answer, 294. Always be careful with those. They love doing that to make sure you're paying attention. 14, y equals 9x plus 12 and x plus 7y equals 20. The solution to the given system of equations is x and y. What is the value of y? Two ways that you can do this pretty quickly are either graphing or through substitution. Graphing is probably a little quicker in this particular case, but I'm going to show you substitution. If you are graphing it, you're just going to put both of the equations in your graphing calculator and look where they cross. And then make sure you're putting the y value of that solution, because that's the little trick there is, wait, put the y value, not the x. So if you're going to do this, if you're going to solve it mathematically without using, the graphing calculator, the other ways we do systems of equations are elimination and substitution. Elimination is where you're going to add the two equations together and you want either the x or the y to cancel out. So if you're presented with a system of equations where you have a positive x and a negative x, or like a positive 2y and a negative 2y, and oh, when I add them together, it's going to cancel out and leave me just an x or a y, then those elimination can be pretty fast, and it's a good option. Substitution usually takes longer, but with this particular setup, substitution is going to be the way to go. Substitution is where you solve for one of the variables in either of the equations, and then you plug it into the other equation. So, for example, this one, they've already solved for y. Y is equal to 9x plus 12. So you go to the other place, the other equation, and wherever there's a y, you plug in 9x plus 12. So, if we do that, we're going to get x plus 7 times 9x plus 12 equals 20. We distribute this. We have that, bring down that x. And then 7 times 9 is 63x, and 7 times 12 is 84. And that equals 20. So x plus 63x is 64x plus 84 equals 20. Then we subtract 84. Whoa, put a 2 there. I'm getting ahead of myself. Subtract 84 from both sides, because we're undoing that, adding 84. We do the opposite. We subtract 84. So on the left, I just have that 64x equals 20 minus 84, or negative 64. Then, since x is being multiplied by 64, we need to divide both sides by 64 to get rid of that. And go over here. We get that x is equal to negative 1. That, however, is not the end of the work. We need to take this negative 1 and plug it into either of these equations to solve for y. I'm going to do the top one, where it says y is equal to 9 times x plus 12. And that x we've just said is negative 1. So 9 times negative 1 is negative 9 plus 12. That would be 3. So that is my y. So the solution to this given system of equations is negative 1, 3. But they asked for the value of y, so that's 3. Yeah, in this particular case, I mean, I'm all for doing things by hand. I love doing things by hand. I'm weird like that. But in this particular case, I would advise you to graph it, to use a graphing calculator. I think that's faster. I'm always for what saves you time. I want you to understand what's going on. Absolutely, definitely important, but you need to know when it's better to do it manually and when it's better to use a calculator, so that you have the best chance of getting it right and getting it right quickly. All right, that was 14, answer being 3. I'm moving on. Right, 15. A circle in the xy plane has the equation x minus 13 squared plus y minus k squared equals 64. Which of the following gives the center of the circle and its radius? Equations of circles follow this format that it looks very fancy, but it's really very straightforward. So it's x minus h squared plus y minus k squared equals r squared. So h and k is the center of the circle and r is the radius. And that's it. So if you notice here, come on, it's minus h, but the center
is just h, and here it's minus k, but the center is just k. So it's always the opposite. Always the opposite. So if this were x plus 2 squared, that h would be negative 2. Y minus 5 squared, k would be 5. So it's the opposite of it. So we use that rule. Come on, there we go. And we look at our equation that we're given, and it says x minus 13 squared plus y minus k squared. So the opposite of this, or positive 13, and then the opposite of negative k, positive k. There's my center, 13k. And this 64 is my r squared. So I just need to take the square root of both sides, and I know that r is equal to 8. So the center is at 13k, and the radius is 8, and that is option A. And that's all there is to it. You don't have to do anything. In fact, you don't have to do any math and calculations, and you really can't graph it because we have that k for as the variable. And I think that's the intent there, is to make sure that you know what the equation of a circle is. If you had forgotten this, this standard formula for a circle, one thing you could do in a situation like this is plug in a random number for k. Like say if you plugged in 4 and then you graphed it and then you noted that the center of that circle was 13, 4 in that case. And you're like, oh, okay, so whatever I put in for k is the y value of the center. That's a way you can do it. You could do this kind of thing if you forgot it, but it's a very good equation to know. I would say just memorize this. It's good. It shows up a lot. 16. The function f is defined by f of x equals the absolute value of x minus 4x. What value of a satisfies f of 5 minus f of a equals negative 15? Okay. So we have this absolute value of x minus 4x, and then we want to know what happens when we plug 5 in there, a in there, and we want it to get to negative 15. All right, so let's set it up. So we have that first one. This is going to be my f of 5, and this is going to be my f of a. And I want it to equal negative 15. Well, first, let's plug in the 5. I'm going to plug it in wherever there is an x. So 5 minus 4 times 5. 4 times 5 is 20. 5 minus 5 is negative, 5 minus 20 is negative 15. The absolute value of that is positive 15. So 15 minus the absolute value of x minus 4x. But this is going to be my f of a, so let's plug a in there. A minus 4a equals negative 15. Okay, so I'm going to start solving this. Now I've only got one variable in here, so I can start to solve for a. I've got this positive 15 over here, so I'm going to subtract 15 from both sides. And I get negative absolute value of a minus 4a is equal to negative 30. So I can either divide or multiply both sides by negative 1. Gives the same result. On the left, I now have my absolute value of a minus 4a equals negative 30 times negative 1 is positive 30. Okay, so to solve for a, when you have an absolute value, you have to take two options into consideration. One is that whatever is in here had a positive solution, a positive outcome, or whatever's in there had a negative outcome, and then it was turned positive by the absolute value. So to solve it, you'd have to do two different options. You have to say when a minus 4a equals a positive 30, or when a minus 4a equals a negative 30. So a minus 4a is negative 3a, and that's on both sides. Except in one it's a positive 30, and one it's a negative 30. Funny little negative I did there, negative 30. So in both of these I'm going to divide by negative 3. When I divide by negative 3 here on both sides, I get a is equal to negative 10. Same thing over here. I divide both sides by negative 3, and I get a is equal to a positive 10. So a can be negative 10 or it can be positive 10. So let's go up and look at my options up here. And sorry, I made it so big so you can't see the whole thing. Sorry about that. There we go. C is 10. And if we go back and we plug 10 in here for A, this all should work. And we can do that if we want to double check. This is one of those things where if you have enough time at the end, I recommend going back and double checking by doing things like this, by plugging stuff in. So if I have, that's my two equations. First one I plug in 5, so 5 minus 4 times 5 minus, and I've said it could be 10 minus 4 times 10. There's my A. Does that equal negative 15? 4 times 5 is 20. 5 minus 20 is negative 15. Absolute value of that is 15. And here, 4 times 10 is 40. 10 minus 40 is negative 30. So the absolute value of negative 30 is positive 30. So 15 minus 30, does that equal negative 15? Sure does. 10 is my answer. (17) For the exponential function f, the value of f of 0 is c, where c is a constant. Of the following equations that define the function f, which equation shows the value of c as the coefficient or the base? This type of problem has showed up before, and it usually sends people into like a little bit of a whirlwind going, what is going on? Because this isn't a format that you normally see in a math class. Okay, all of these functions have the same value. They all do. That's what this part means. When it says, for this function f, the value of f of 0 is c, where c is a constant. Of the following equations that define the function f, all of them define the function f. All of these are the same. And you can see this by plugging in 0 for x. So if you did 22 times 1.5 to the power of 0 plus 1, or if you did 33 times 1.5 to the power of 0, or 49.5 to the power of 1.5 times 0 minus 1, or negative 1, or if you did 74.25 times 1.5 to the power of 1 minus 2, or, 0 minus 2, or negative 2. If you put these into your calculator, you will get the same answer. You will get a constant, the same number every single time. So what is that constant? You don't actually have to use your calculator. You might think like, what are you talking about? 74.25 times 1.5 to the power of negative 2? Oh, I'm using my calculator. And if it was just this one, I would totally agree with you. But we've got this one right here. Anything besides 0 to the power of 0 is going to be 1. So since it's 1.5 to the power of 0, that's just 1. 33 times 1 is 33. I don't need my calculator. Save myself a little time. And I already know now it says that all of these, when you put 0 in, you get the same constant, c. This is c. C being what you get when you plug in 0 and you do the math. So now, okay, we know c is our constant. C is 33. So what is the question? Which equation shows the value of c as the coefficient or the base? The coefficient on all of these is the number that's out here that's multiplying by the number that's going to the power. And what is the number that goes to the power? That is the base. So each of these has 1.5 as the base of its little exponential. and then it has a coefficient out front. For A, the coefficient is 22, B, it's 33, etc. So it's saying which of these has 33 as its coefficient or its base? That would be this one right here. It has 33 as the coefficient. None of them have it as the base. They all have 1.5 as the base. And then we just look at the coefficients. 33. There it is. B is my answer. Again, this is an oddball, but I've seen it before. I've seen this exact format where it's, here's 4 functions and they all have exponentials of x and x minus 1 and x minus 2, and which shows this is the value. And yeah, it's one of those, it doesn't look like anything you're likely to have seen before in math, so it can be kind of like, what? So it's a good one to practice and recognize because they've done it before, they'll likely do it again. Number 18. The function f of t equals 40,000 times 2 to the power of t over 790 gives the number of bacteria in a population t minutes after an initial observation. How much time in minutes does it take for the number of bacteria in the population to double? This little population growth formula, it's p sub 0 times r to the power of t. They use this a lot, which is your initial population times rate to the power of time, whatever units of time you're doing. Like how many, is it doubling every minute, every hour, every year? Those are going to be your units of time. This is one they use a lot, but they don't really tell you this. They will just give you this equation and be like, here you go. And they want you to know which of those numbers is the initial population, which is the rate, and which is the time. We look over here, 40,000 then is our initial population, and the number that is the base for this exponential is the rate. So it's doubling, growing by 2, you're multiplying it by 2 every t minutes. In this case, there's a little wrinkle here that it's t over 790. Okay. So how much time in minutes does it take for the number of bacteria in the population to double? Well, once we know 40,000 is the initial population, for it to double, it would have to be 40,000 times 2, right? Well, we've got this times 2, but it's being raised to the power of t over 790. What would t need to be for this just to be 2? Like after I do this math, I'll just get a 2. If it's 2 to the power of 1, it's just going to be 2, right? So I want this to be equal to 1. T over 790 has to be equal to 1. And you can set this up as an equation that t over 790 equals 1. Absolutely can do it that way. And then I didn't give myself enough room. I multiply both sides by 790, and I get that t is equal to 790. And that's it. You also could look at it as, without actually writing out the math, you might go, a number over itself is equal to 1. So if 790 is on the bottom, 790 must be on the top too. Also equally valid. Whatever makes the most sense to you, that's what you should do. Okay, so back to our original little equation here. So if I put 790 in here for t, 790 over 790 is just 1. Then I have 40,000 times 2 to the power of 1, 40,000 times 2. That doubles it. So if t is 790, then the population has doubled, 790 minutes. And that is B. If you don't remember, come here, get rid of that. If you don't remember this little formula, and if you were to look at this and go, which of these is the population? What is it? The shorthand way that you can do this to help you remember which one is the initial population is the initial population is what is present when it's 0 minutes after it started. No growth has happened. 0 minutes have passed. So if you plug in a 0 for time and you do this math, 40,000 times 2 to the power of 0 over 790. 0 divided by 790 is just, come on eraser, is just 0. So 40,000 times 2 to the power of 0. 2 to the power of 0 is 1. 40,000 times 1 is 40,000. So if you're plugging in, if you forget this equation, which it's easy to forget, totally understandable if that happens, it's not provided, it's not used that often. So if you forget that formula, that's how you can remind yourself which part of this represents which. So in this case, when you plug in 0, you get 40,000 at 0 minutes. So you know, 40,000 is the population. It needs to be doubled. It needs to be multiplied by 2. How do I get there? But yeah, this is another one of those formulas that it's good to know because it comes up a lot and they don't provide it. Especially in these exponential word problems, that's where you're going to see it a lot. Number 19, 12 over n minus 2 over t equals negative 2 over w. The given equation relates the variables n, t, and w, where n is greater than 0, t is greater than 0, and w is greater than t. Which expression is equivalent to n? Okay, this is a variation on the type of problem that they absolutely love, which is that which expression is equivalent to n. It also can be phrased as put in terms of w and t. That is a phrasing they love. Put it in terms of w and t. You can also say solve for n. That's another one. They use all these interchangeably and they use them all the time, so you need to know how to do this. What they want you to do is they want you to use your algebra skills that you use when you're solving for x, trying to find a numerical value for x. Here that's not possible because we have multiple variables, so you cannot find a numerical value of x, or in this case n. But you can get n by itself and then everything else on the right side, and that's what they want. When you have multiple things going on in a problem like this one, you have 12 over n, 2 over t, t over w, 2 over t, t over w. There's more than one way to kind of manipulate them. You're all going to get to the same end. So I'm going to show you the way that I chose to do it, and the College Board, and if you look at their explanation, theirs is a little different. And actually, when I took this the first time, I did it yet a third way. Because I looked back at my notes, I was like, oh, I did it even a different way then. So there's multiple ways. Just be consistent, be careful, and always do the same thing to both sides, and you're not going to, you're not going to get a wrong answer. You might find you're making things more complicated. You may have to backtrack a little bit. That's common. You just got to keep trusting the process. Okay, so here is my preferred way to do it. 12n minus 2t equals negative 2 over w, or negative 2w. I like to get the little n fraction by itself first. So I'm going to move this over to the other side. It is minus 2t, so I'm going to add 2t to both sides. Then I get 12 over n equals 2t minus t over w, because that's that negative, keep saying tw, minus 2 over w. So it's a little mental block. I keep saying t instead of 2. So 2 over t minus 2 over w. And that is what 12n is equal to. At this point, you could say I'm going to multiply everything by n. I think it's easier to keep everything together and to keep it a little simpler in the next stages by combining this first. Just trust me on this. It's going to be a little easier for you. So to combine those, they have to have the same denominator. Since they are two different things, there is no least common multiple that we know of because we don't know what they're equal to. We just have to multiply them by each other. So that means 2 over t, we have to multiply by w over w. And then 2 over w, we multiply by t over t. That will get us a tw denominator for both of them, and then we can combine them. So on top, 2 times w is 2w over t times w, tw. And on the bottom, the other equation there, or the other calculation, 2 times t is 2t, and w times t again is tw. So now I can replace those over here. So that's tw. I keep saying t and 2. I keep flipping them. 2w over tw minus, because we don't want to forget that minus was there, minus 2t over tw. We can combine them, and it becomes 2w minus 2t over tw. The reason I like this is because now we can cross multiply and get rid of all of the fractions at once. Poof, they're gone. And I like that. So let's do that. Let's cross multiply. First, n times 2w minus 2t. I am not going to distribute. Then 12 times tw. Since it is n times this block, this binomial, I'm going to divide both sides by that binomial. 2w minus 2t, and I get n is equal to 12tw over 2w minus 2t. And you'll notice this does not match anything that we have over here. You're like, wait, what have you done? You got it wrong. No, it just needs to be simplified. It's because there is a greatest common factor for all three terms. While they do not share a t or a w, they do have numbers in front of them that are all divisible by 2. Yes, we have a 2, and a 12. So I can pull a 2 out of the top. 2 times 6tw. On the bottom, I can pull out a 2 of w minus 2, and I can cancel those 2's. And so I am left with 6tw over w minus t as being equal to n, and that is d, right there, 6tw over w minus t. You may have wondered what the whole point of this n is greater than 0, t is greater than 0, w is greater than t. All that is doing is it's telling you that all of these numbers are positive. It's not a clue to help you solve for the values of them. Which honestly, when I first saw that, when I first read that, I'm like, wait, are they wanting me to try to figure out the values of this? That they're telling us it's greater than 0? No. They're just letting you know it's positive. Because if t is greater than 0, it's positive. And if w is then in turn greater than t, it must also be positive. So when you get to a certain point, like if you get to this point here, you can flip them, which I'm pretty sure is what they did in the answer key for this, what the College Board did. Because none of them are equal to 0. They're all positive. So then you can flip them and say that n over 12 is equal to tw over tw minus 2t. And I'm pretty sure they did that at that stage in the College Board. I know they flipped it at some point. I have to go back and look at it to be 100% sure. But that's the only reason they did it, is so that if you wanted to flip the fractions once you've combined them, then you could. But I think cross multiplying is an easier way to get to that final answer. But yeah, there's more than one way to go about this. That's the way I preferred, and the answer is D. All right, number 20. During a study, the temperature in degrees Celsius of the air in a chamber was recorded to the nearest integer at certain times. The scatter plot shows the recorded temperature Y in degrees Celsius of the air in the chamber X minutes after the start of the study. What was the average rate of change in degrees Celsius per minute of the recorded temperature of the air in the chamber from X equals 5 to X equals 7? Whew, that's a long route to get to for what is, at its heart, a very basic question. They're throwing a lot of confetti in the air, but all that they're asking is, here's a point, here's a point. When X is 5, when X is 7, okay? If I were to draw a line between those 2 points, what would the slope of that line be? That's all they're asking. That's what this average rate of change means. That's it. So all the other information that's here, I mean, it's good to know what a scatter plot is. A scatter plot is a way to present data that was recorded. Here they are saying after 1 minute in the chamber, it was 4 degrees. After 2 minutes, it was 6 degrees. After 3 minutes, it was 12. After 4 minutes, it was 10. That's all it's showing. It's after the time in minutes and the temperature in degrees, so that we can see that data. A lot of questions on the SAT that are about scatter plots will also have a line of best fit. Don't worry, you will never on the SAT, as of the time of this recording, have to calculate on your own what is the potential line of best fit. If they provide one, they will ask you, the only questions they really ask about lines of best fit are, here's a line of best fit, what do you think its equation is? Or, here's a line of best fit, according to the line of best fit, what is the value when x is 6? That's the only way they show up on the SAT. And this is the other sort of variation where they're just asking you to pull data from the scatter plot. So here again, it's x is 5. When x is 5, the temperature is 14. And when x is 7, the temperature is 24. So the average rate of change in degrees Celsius per minute here is just the slope there. And slope is rise over run, or change in y over change in x. So you can do it any way you want. You can actually kind of count up here and do rise over run if you want to. That's totally fine. You can also do change in y over change in x. 14 minus 24 over 5 minus 7. Just make sure you're going in the same direction each time. You can pick either pair to start with. You could have also gone 24 minus 14 over 7 minus 5. Same difference. So 14 minus 24 is negative 10. 5 minus 7 is negative 2. Negative 10 divided by negative 2 is positive 5. And that's it. 5 is your answer. Like I said, over here you could have counted the same thing and said, okay, the change in y from 5 to 7, it goes up. We're at 14, it goes up to 16, 18, 20, 22, 24. Okay, so it goes up 2, 4, 6, 8, 10. It goes up 10. And this, it goes over 1, 2, 2. 10 over 2 is 5. That's the only thing I think they might get some students with on this one, is because each of these jump ups represents 2. Going 14 to 16 to 18 to 20 to 22 to 24. And some might count that as 5. Going, oh, I went up 5 and then I went over 2, so it's 5 over 2. I can see students doing that. So always, always, always check the scale over here as to which, how much each tick up represents. But your answer here is just 5. That is the slope or the rate of change. 21. In August, a car dealer completed 15 more than 3 times the number of sales the car dealer completed in September. In August and September, the car dealer completed 363 sales. How many sales did the car dealer complete in September? All right, so August and September. So it's saying in August, it did all this compared to what it did in September. So I'm going to call September S. That's my variable S. So in August, they completed 15 more, adding 15 more than 3 times the number of sales in September. That's how that breaks down. 15 more than 3 times the sales in September. Then they tell you that in August and September, together, the car dealer completed 363 sales. So let's add them together. So August was 3S plus 15, and September was S, and together that equaled 363. So I can combine those two. 3S plus S is 4S plus 15 equals 363. Then to solve for S, I need to undo what's been done to S. So I'm going to subtract that 15. That's the opposite of adding 15. And then I get that 4S is equal to 348. Then I need to divide both sides by 4. Since 4 is being multiplied by S, I need to divide to undo that. So I get S is equal to 75 is 87. Yes. Okay, just double checking the math in my head. So S is 87, and they did want to know how many the dealer completed in September. And we said our value for September is S. So it is 87. They absolutely could have asked for August, in which case you would have plugged in 87 here, multiplied it by 3, then added 15. Or you could have just subtracted it from 363 to see what they did in August. So just always be careful. Again, they're asking for September, so it is 87. That is my answer. Number 22. Points Q and R lie on a circle with center P. Okay, so this is not to scale, but I'm just making a little drawing for myself. All right, so the center is P, and there are points Q and R on a circle. Okay. The radius of this circle is 9 inches. Okay, well, any line connecting the center to a point on the edge is a radii, is a radius. They are radii. It's a radius of a circle, so I have 2 radii here, so I know they are both 9 inches. Okay. Triangle PQR, boop, all right, triangle PQR has a perimeter of 31 inches. What is the length in inches of QR? Okay, we don't have to do any sort of fancy math here. We don't have to figure out, the altitude of this triangle. We don't have to figure out the area. We don't have to do angles, nothing like that. It is a very straightforward perimeter problem. So when we have the perimeter of a triangle, all we're doing is we are measuring and adding up the lengths of the sides. So if we call that side X, that side QR, which is what we want to know, the perimeter of this triangle would be 9 plus 9 plus X, and the total perimeter would be 31. So we combine 9 plus 9, that is 18. 18 plus X equals 31. So to solve for X, I need to undo what's been done. 18 has been added, so the opposite of that is to subtract 18 from both sides, and I will get just an X on the left and 31 minus 18, or 13 on the right. And that's B. As you can see here with their other options, we got a couple of square roots of 2 going on. They're really trying to make you go, oh, this is an isosceles triangle, so I have to figure out, a square root of 2. No. No, they want you to go down that path. They're wanting you to think it's a 45, 45, 90 triangle, in which case that's A times the square root of 2. That is a formula you need to know. It is provided for you, but that's clearly what they're trying to get you to think, that this is a right angle. They never said it's a right angle. Nowhere in this problem does it say it's a right angle. It just says the 2 points Q and R are on the circle. Each of those is a radius of the circle, and the perimeter is 31. So it's not as fancy as they're trying to make you think. And the answer is just B, 13. Number 23. In a set of 4 consecutive odd integers where the integers are ordered from least to greatest, the first integer is represented by X. Okay? The product of 12 and the fourth odd integer is at most 26 less than the sum of the first and third odd integers. Which inequality represents the situation? That's one of those where I suspect a lot of people's eyes start glazing over. All right, let's set up our little equation, our little descriptors, I should say, of our integers. Okay, so we have our first integer, we have our second, our third, and our fourth, and they are all odd integers. So how do I get from a number to the next odd integer? And it is itself an odd integer. Well, let's put a real number in here and say, okay, if this was 3, how would I get to the next odd integer of 5? I would add 2. Then to get to the next odd integer of 7, I would add 2 again. So to get from 3 to 7 would be adding 4. Then how about 9? I would add 2 again. So to get from 3 to 9, I'd be adding 6. That is how we're going to represent them, because we only have the first integer being X. So the second odd integer is going to be X plus 2. The third one is going to be X plus 4. And the fourth one is going to be X plus 6. And I think that may throw some people, because they might see 2, 4, and 6 and think like, but those are even numbers and these are odd. Yeah, but we're starting with an odd, and then when you go 2 up from an odd, you're at an odd yet again. Okay, so now we have our representations of them. So it says the product of 12 and the fourth odd integer is. I'm going to pause right there, because the is usually an equals point. But there's a little bit of a flurry here, a little flourish. It says not just is, it's is at most. Okay, so this is an inequality. All right, so the product of 12 and the fourth odd integer, 12 times the fourth odd integer, okay? It is at most. So the most it could be is this other thing we're going to do in a second. So the most it could be, but it could be less than that. So this is a less than or equal to. So it could be this. At the most it would be this, but it's probably less than that. So it is at most 26 less than, so I'm subtracting 26. It is, let me erase this so it can be clearly seen, 26 less than the sum of the first and third odd integers. Okay, so my first integer is x, and my third is x plus 4. So I am adding x plus 4, and it's 26 less than that. All right, so let's look at this one more time. Just make sure we've written it correctly. It is the product of 12 and the fourth odd integer. Okay, 12 and the fourth odd integer, all right, is at most less than or equal to 26 less than minus 26, the sum of the first and third. The first and the third, sum of the first and the third. Okay, 12 times x plus 6 is less than or equal to x plus 4 minus 26. I look over here to see which answer matches that, and that would be A. That is my answer. Number 24. I have a table, x and y, x being negative 2s, y 24, x is negative s, y is 21, and x is s, y is 15. The table shows 3 values of x and their corresponding values of y, where s is a constant. There's a linear relationship between x and y. Which of the following equations represents this relationship? This is an oddball. It just is. This is what I would classify as a puzzle problem because it's taking things you know but presenting them to you in an unusual way that you're unlikely to have seen before. So you have to get a little creative. Okay. They want us to know the linear relationship, the equation for this linear relationship. A linear relationship, most commonly see it as y equals mx plus b. That is not the format these are in. These are in standard form, where it's x plus y equals a number, or ax plus by equals c. You know, that's the standard form, ax plus by equals c, where a, b, and c are constants. We don't use it as much. So I think with this case, I think for me, the best way to do it was to put it into our slope-intercept form and then convert it into standard form to see which one of these it matches. Right, so the slope and the y-intercept. Slope is change in y over change in x, and we can do that over here with what we're given. So we can take these 2 points, any 2 points, it doesn't really matter, and I'll say change in y. So y1 minus y2, 15 minus 21, and then I go the same way over change s minus negative s. That's change in y over change in x, and I can go either direction, it's fine. Okay, so 15 minus 21 on top is negative 6, and s minus a negative, which is the same as plus a positive, is 2s. So I can simplify this because 2 goes into both negative 6 and 2. It goes into 2 one time, and it goes into negative 6 3 times. So my slope is negative 3 over s. Okay, so now I know my slope. That is negative 3 over s. Okay. All right, now on to our y-intercept. There's 2 ways you can look at this. One is sort of more intuitive, and one is more just using the math you've already learned. Both are fine. Both get you the right answer. So the way you've learned it is, once you have an equation like this, you plug in an x and a y, and then you can solve for b, your y-intercept. So I'm going to use this bottom one here, s and 15. So y equals negative 3 over s. My x is going to be s, and my y is 15. Okay, so negative 3 divided by s times s, those s's cancel out. So I get 15 equals negative 3 plus b. So that's a negative 3, a minus 3. I'm going to undo that by adding 3 to both sides. And I get that b is equal to 18. And that is my y-intercept, is 18. I'm going to go ahead and put that up here. Okay, another way that you could look at this, which is equally valid, if you're looking at this chart over here, come on, there we go. If you look at this chart over here up close, I'll zoom in a bit. It is linear, but things in this chart are not going up the same. So here it goes down 3, and then it goes down 6. Now, wait a minute, what's going on? It goes down by an S, or goes up by an S, excuse me. Then it goes up by 2 S's. Like, what? So they're missing something. If you have negative S and positive S, what's going to be right smack dab in between them? Put any number in there. Negative 5, positive 5. Negative 100, positive 100. What's the number directly in the middle between those two, between a number and its opposite? It's 0. It's because they both have the same absolute value. They're both the same distance from 0. Any number you put in there, this is going to work. 0 is the number that's right in between there. When x is 0, what is y going to be? It's jumping 3, then it would jump 3 in the middle, and then another 3. So jumping 3 down from 21 would be 18. So when x is 0, y is 18. That's the y-intercept. That's another way to look at it. Both, again, totally valid, will get you to the same result. So now I have my equation, y equals negative 3 over s times x plus 18. But if I look over here, there are no fractions. So even if I move this over here, I still got to get rid of this fraction. So since that's being divided by s, I can multiply both sides by s. And that will get rid of this fraction. So on the left, I have s times y, sy. Then I have negative 3 over s of x. I'm distributing that. When I multiply it by s, that disappears, so it becomes negative 3x. And then plus 18 times s. Okay. Now I want the x's and the y's on the same side, so I'm going to add 3x to both sides, and I get 3x plus sy equals 18s, and that is B. Yeah, so it is a more, once you see it, once you kind of get past the S of it all, it is more just a, here's a selection of points on a line, find the slope. Now, once you have the slope, use it to calculate the y-intercept. But just that S does make things a little wonky. It makes it very easy, because you can see how close they all are when you look at those over there. It makes it very easy to make a simple error in calculation and get the wrong answer on this one, so just be careful. Number 25, which of the following expressions is equivalent to sine of 24 times cosine of 66 plus cosine of 24 times sine of 66? If you want to solve this on your calculator, you would have to input all this, be very careful to do it accurately, get a result, and then input each of these separately and see which of the results that you get matches what you got when you did that math. I think there's a better way to do it. That is definitely a viable way. It's not wrong. You absolutely can do it that way if you'd like. When I looked at this, what struck me is I'm like, okay, that seems like an awful lot. There's got to be a shortcut. There's got to be a way to do it where I don't have to do all this. 24 plus 66, and those are the two numbers were being used in both of these little parts of this equation, of this sum, I should say. If you add those together, you get 90. So these are two angles in the same triangle, the same right triangle. It's going to be kind of like that, maybe. Okay, so there's my 24, and there's my 66, and there's my right angle. Okay. Let's call this x, y, and z. So what's going to happen when I put x, y, and z into this over here? So, okay, sine of 24 times cosine of 66. That's the first one. Okay, so the sine of 24. Sine is opposite over hypotenuse. So it would be y, that's the opposite, over the hypotenuse z. So y over z. What is the cosine of 66? Cosine is adjacent over hypotenuse. So y over z. All right, so they are equivalent. Sine of 24 and cosine of 66 are the same thing. They are the same. Sine of 24 is the same thing as cosine of 66. And I've got a sneaky suspicion the same thing's going to happen over here. But let's just be careful. Let's do what we're asked to do, just to be sure. We don't want to assume something and get it wrong. Cosine of 24 times sine of 66. That's the second part of this. Cosine of 24. 24, this is the adjacent. This is the hypotenuse, so it would be x over z. Sine of 66 is the opposite over the hypotenuse, so again, x over z. Sure enough, cosine of 24 and sine of 66 are the same thing. So look at our options here. 2 times the cosine of 66 times the sine of 24. That doesn't look right, because this right here, sine of 24 and cosine of 66 are the same thing, but it's not the same thing as cosine of 24. These two groups are not equal to each other. They are not. So when these are being added, I'm not adding the same thing twice. So no, that is not, A is not an option. Number 2, 2 times the cosine of 66 plus 2 times the cosine of 24. Well, sine of 24 and cosine of 66 are the same thing. So I could put cosine of 66 in here for sine of 24. But is that 2 times the cosine of 66? No, this is the cosine of 66 times itself. So that would be cosine of 66 squared. Okay, so now we're looking at C and D. Cosine of 66 squared. That looks right, but what about the second part? Cosine of 24 times sine of 66. These are the same, so we could change either one. I can change this to be cosine of 24, or I could change cosine of 24 to be sine of 66. But because both of these are using 24, I'm going to go for the cosine of 24. And now I have cosine of 24 times cosine of 24 is cosine of 24 squared. It is C. So again, this is all going to be about if when you look at these and you realize, wait a minute, 24 and 66, okay, that's the sneaky thing that's going on. They're in the same triangle. Now, I did all this to show you, why this is true. But this is one of those things that's a good to know, even just for your math class, it's good to know, is that if you have a right triangle, the sine of one angle is always equal to the cosine of the other angle. We're not talking about the right angle. We're talking about the two non-right angles. The sine of one is equal to the cosine of the other, and vice versa, every single time if they're in the same triangle. And this is why. Because for like the cosine of this one is cosine of 66 is adjacent over hypotenuse, and the sine of 24 is opposite over hypotenuse. So as soon as you see that they're 90, you're like, wait a minute, I got some things that are the same. This is one of those facts that doesn't come up that often, but if it does come up, it's going to be in these upper level, higher number. When I say upper level, I mean like the number 25, 26, 27, those numbers on the test. So if you're really, aiming for like, I want to get the big scores on this, it's a good thing to know. Good thing. It doesn't show up on every test, but when it does, it's make it or break it. Number 26. The cost of renting a carpet cleaner is $52 for the first day and $26 for each additional day. Which of the following functions gives the cost C of D in dollars of renting the carpet cleaner for D days, where D is a positive integer? Not gonna lie, when I first saw this, I thought they had made a mistake in their answers. I was like, oh, someone made a boo-boo. They did not. There's a little trick to this one. Okay, so the cost of renting a carpet cleaner. It is $52 for the first day. All right. And then for each additional day, it is $26 per day. So, okay, so $26 times the number of days, right? This would give me the cost, of like, okay, after the first day, this is how many days I've rented it for each additional day. But here is the problem. It's not, we can't do that because 26 for each additional day. That's what I'm treating the D as here. But is that what D is? It says, which of the following functions gives the cost C of D in dollars of running the carpet cleaner for D days? So that counts this first day. It's included. It's like, wait a minute. So if I put in a 1 here for D, like, all right, then that's going to be 52 plus 26. That's not how much I'd have to pay if I rented it for one day. I would only have to pay it $52 for that first day. So how can I represent that? What would it be? Eraser, there we go. How can I make this so that if I put in a 1 here, I will get $52 for the first day? Well, what if I changed this into an X? I know $26 a day has got to be part of this. I know that. But how can I say, all right, what's it going to be? What should that amount be, that X be? How can I solve this? Well, I know the first day it's going to cost me $52. And I know that D is 1 day. I've rented it for 1 day. Now I have a very straightforward equation that I can solve very easily. So X plus 26 times 1 is 26 equals 52. And then I want to undo what's been done to X by subtracting 26 from both sides. And I get X on the left and 52 minus 26, or 26 on the right. So it should be 26 plus 26 times D. And that will equal what I have to pay. And this will work. So if it is 1 day, I get 26 plus 26, or $52, which is what they told us. They said it was $52 for the first day. And if it was 2 days, then 26 times 2 is 52 plus 26. And that's what it said. That 52 for the first day and then $26 each additional day. So if I do that, if I put the 2 in there, I will get 78, which is what I want. 52 plus an additional 26. Okay, so that one, it's a little sneaky, because most of these types of problems where they want you to say what equation represents the data, usually the numbers that they provide are gonna be somewhere in here. 9 times out of 10, if not more so, all of the numbers that they give you end up in this last one. So it is so easy to do, and I admit I absolutely did it the first time I went through. I'm like, wait a minute, but that doesn't work. When I looked at it, I very confidently wrote down, okay, 52 plus, and I'm like, wait a minute, but that would mean that you're paying $78 the first day, and that's not true. What's going on here? Yeah, they're being sneaky. They're being sneaky. 52 does not show up in the answer. The answer is A. C of D equals 26D plus 26. All the other ones have 52 because they are counting on you to think, as I thought too, my initial thing, 52 must be in there somewhere. It is not. So, yeah, be careful with those, especially, this is the big clue, that it's a number 26 problem, but it looks like it's just, okay, 52 plus 26D, okay, I'm done, move on. Unlikely if it's a number 26. Possible, but not as common. Usually there's a twist, and that's what the twist was in this case. All right, last one. Number 27, f of x equals x minus 2 times x plus 15. The function f is defined by the given equation. For what value of x does f of x reach its minimum? Now, I just finished saying for number 26, if you have watched this video, if you're watching the full-length video, or if you just watched that previous individual video and saw what I said about 26, where I said usually in these upper numbers there's some kind of twist or some kind of trick. That's what threw me on this one, because I'm like, what's the trick? It's number 27, and they're just giving us a quadratic and saying, what's the minimum? There's no trick. It really is that straightforward. So, 2 ways you can do this. You can plug it into your graphing calculator, and then, wherever it ends up, you find the minimum, and then you say, what is the x value at that minimum? That's it. If you want to do this manually, the way you would do this, I go x minus 2 times x plus 15, and I would distribute this. So x times x is x squared. X times 15 is 15x. Negative 2 times x is negative 2x, and negative 2 times 15 is negative 30. Combine those like terms, and we get x squared. 15x minus 2x is 13x minus 30. Once you have the equation in this format, the easiest way to find out where the maximum or minimum, it is a minimum in this case, is to use the formula for the axis of symmetry. That will give you the x value of that minimum, and that's all they want. They want the x value. The formula for that is negative b over 2a. When we say a, b, and c, we're talking about the coefficients in front of these. So the coefficient in front of the x squared, if any, is a, coefficient in front of the x is b, and the term that's by itself is c. And always make sure that you keep those signs with them. They do go with those coefficients. So here, negative b over 2a, the opposite of b over 2a. B is a positive 13, so the opposite of that would be negative 13. My a here is an invisible 1, so 2 times a is 2. And that's it. X is negative 13 halves. And you absolutely can put that in a decimal format, so it would be negative 6.5. Those are the two ways you can write it. Do not put it as a mixed numeral because this is a student-produced response question. If you were to put this as negative 6 and 1/2 like that, you would get it wrong because it's going to view it as like negative 61 halves. It's not an option. Don't do it that way. Be careful. So negative 13 halves or negative 6.5. Again, graph it or distribute and use negative b over 2a to get your x value. So just as a little reminder, the axis of symmetry is if you have a parabola, it's that line that goes straight through the middle of it and divides it into two symmetrical halves. And so it goes right through the vertex. So it's really good for finding when it says like, what's the x value at the minimum or what's the y value at the maximum? Once you find that axis of symmetry, that gives you the x value, and that's all they wanted here, so we're done. If you wanted the y, you would take that x value and plug it into the original equation, do the math, and that will give you the y value for the vertex. But yeah, that one was more straightforward than I would expect for a number 27 problem, but you have reached the end of this module. Congratulations. Hey guys, the full insanely comprehensive SAT math prep course I've been promising for so long is live right now at mathwithalyssa.com. And of course, you can also still get the free 10 video course on SAT tips and tricks at mathwithalyssa.com as well. You also can now book one-on-one tutoring sessions with me. Links to how you can do that are in the description and the pinned comment below. And as always, if the video you just watched was helpful or useful in any way, please let YouTube know. Comment, like, share, subscribe. You know the drill. Thank you so much for watching. Hope you have a great day. See you later. Bye.